Hi, this is Ms. Meadows, and in this presentation, we are going to discuss significant figures and measurements. Our objectives in this lesson are to learn how to read measurements properly, how to record measurements, and determining the number of significant figures in a value. So how do we read measurements properly? When reading a measurement on a digital device like a thermometer, pH meter, or a balance, always record all digits given on the reading. This includes any zeros in the measurement. Do not leave off any digits as they become part of the precision and accuracy of your data. How do we read measurements properly? Continued. When reading a measurement from a device with equal markings, we need to determine what each of the markings represent first. To the left, we see a typical metric or English ruler. On the top are millimeter and centimeter markings. The numbers that we see represent centimeters. So from measurement 1 to 2, there are 10 equal markings in between. Each of these represent 1 millimeter. So there are 10 millimeters in a centimeter. On the bottom are inches. From 1 to 2, there are 16 equal markings. Each of these represents 1/16 of an inch. Above the ruler, we see a teal box. This box measures 2 lines past the 5 centimeter line. This means that the box measures 5.20 centimeters. We add the 0 to show that the last digit could be estimated between the markings as well. This number could also be written as 52.0 millimeters. Below the ruler, we see a green box. It measures 2 lines past the 2-inch mark, making it 2 2/16 inches, or 2 1/8 inches simplified. How do we read liquid measurements properly? We read liquid measurements the same as a ruler, but need to be sure we read the liquid at the same point each time it is measured. Liquids create a curve called a meniscus, especially in thin containers like graduated cylinders. It has been agreed that in science we read the measurements from the bottom of the meniscus. This agreement ensures that measurements can be repeated with precision. The glassware we use is made with this in mind so that the markings on the containers are accurate. On the right, we can see the graduated cylinder with green liquid inside, and we can see that it creates a curve known as the meniscus in that container. Where it says read here is where we would actually read and record the data. For this reading, the meniscus is above the 45 but below the 50 milliliter marks. Each of those markings would represent 1 milliliter, so we would read this as 48.0 milliliters. We can see that the meniscus falls directly on the line, making it 48, and we put 0.0 to indicate that we could estimate one more digit between the markings. Let's take a look at this video to see how this graduated cylinder is read.
In this video, we will learn how to read a meniscus. A meniscus occurs when the molecules of a liquid cling to the side of the glassware you are measuring with. The meniscus is more prominent in glassware with a small radius. When measuring the volume of a liquid in glassware, it is important to read the meniscus properly for an accurate measurement. Start by placing the glassware on a level surface. Position yourself to view the meniscus from eye level. If viewing the meniscus from above or below this level, your estimation of the measurement will be inaccurate. Determine the value of the gradation mark just above and below the meniscus on the graduated cylinder. Visualize a line at the bottom of the meniscus. Estimate where the line is in relation to the gradation marks above and below in order to determine the value for your measurement. We would read this measurement as 9.60 milliliters.
Continuing how we read liquid measurements properly. A burette, pictured to the right, is used to measure how much liquid is delivered into another container. Unlike most volumes that are read from the bottom up, it is read from the top down because we want to know how much liquid has left the container. We're going to take a look on the next slide at some examples of reading a burette and see how this one was read and how we came to the conclusion that it was 22.20 milliliters. Here we can see a ring stand with a clamp holding a burette. The burette is used to measure and deliver volumes of liquid. The valve on the burette, called the stopcock, is at the bottom and can allow for a chemist to control the volume of liquid delivered to another container. In this close-up view, we can see on the left the initial reading of liquid within the burette, and then on the right, the final reading of the liquid volume in the burette after some of the liquid has been drained. You can see here that the burette is numbered from 20 to 25, going from top to bottom. This entire burette would start with 0 at the very top and end with 50 milliliters at the bottom. To read this burette, you have to think about reading the numbers backwards and really pay attention to where the markings are and what they represent. The final reading for this burette, since the meniscus is past 22 but not at 23 milliliters, would be 22, and each of the markings in between represent 0.1 milliliters. Since the meniscus is at the second small mark, we would read this as 22.20 milliliters. The 0 is added because we do have the ability to estimate in between the markings and need to show that the meniscus is right on the marking. In this example, we can see a burette containing an orange liquid with a close-up view of the 14 and 15 markings. The meniscus lies just past the 14 line, but not at the 14.1 line yet. To read this meniscus, it would be 14.05 milliliters. We would estimate between 14.0 and 14.1. Here we can see another burette with markings at 40 and 41, and we can see that the meniscus is kind of blurred and hard to read. What we can do is use another tool to help us read the meniscus. Here we can see the same burette reading, but the meniscus is clearly shown and darkened. To do this, we take a card with a black line and put it behind the burette so that the meniscus reflects that black and darkens, making it easier to read. How many digits do we record? For any device with markings, like the rulers, graduated cylinders, and burets, always record all values from the markings and then estimate one more digit. If we take a look at these rulers, ruler A at the top, we can see that the object is between the markings, so its measurement will be an estimate. Just looking between the markings, I estimated that object to be about 3 centimeters long. If we take a look at ruler B, we can see we have more markings in between the 0 and 10 line, so each marking would represent 1 centimeter. In ruler B, the object is between the third and fourth mark, so we can read the first digit to be 3 and estimate one more. Since it's a little bit past that marking of 3 centimeters, I estimated it to be 3.2. The 2 would be the estimated digit. Looking at ruler C, we can see that between the markings, we now have 10 more markings, so we've split it up. The object is between the first and second marking, between the 3 and 4 on the ruler. So we can read the first 2 digits and estimate one more. We can read the first digit as 3 because it's past the third large line. Since it's past the first small line after that, it would be 3.1 centimeters. And because it lies between the 0.1 and 0.2 lines, we would estimate it to be 3.15 centimeters. If a object fell directly on a marking, we would still estimate one more digit and record it as a 0, and we do this to indicate the accuracy of the measuring device. What are significant figures? The number of digits in a value, often a measurement, that indicates the confidence or precision with which the quantity was measured. That is what a significant figure is. When we look at a value, we want to be able to determine how many significant figures or significant digits there are in that value. Looking at the first one with the balance, we were told at the beginning that any digital reading, we would read all of the digits given to us. That one is 28.7 grams, so it has 3 digits, and those would all be significant. So we say it has 3 significant figures, or 3 sig figs for short. On the right, we have the Buret reading from before. Its value was determined to be 22.20. We added the 0 to show that we could estimate in between those lines. This would mean that there are 4 significant figures in this value, or 4 significant digits. At the bottom, we have the millimeter and centimeter ruler with our teal box. It was recorded as 5.20 centimeters or 520 millimeters. There are 3 digits in each of those values, so this would have 3 significant figures. What this shows us is that the most precise measurement of all of these is the Buret reading with 22.20 milliliters because it has the most significant figures. Going back to our ruler measurements from previous, we want to see how many significant figures were in each of these measurements. On the right, we have the recorded measurements from before. Ruler A was read as 3 centimeters, and that was our estimated digit because we didn't read it from the line. There's only 1 digit in that measurement, so it has 1 significant figure. Ruler B was recorded as 3.2 centimeters, our 3 being a known digit from the line and our 2 being our estimated digit. The value has 2 digits in it, so it has 2 significant figures. Ruler C was read to be 3.15 centimeters. Again, the 3.1 was read from the markings and the 5 was estimated. So this has 3 significant figures. So as the ruler gets more accurate by adding lines and markings in between the larger markings, we get more significant figures in our values, indicating a more precise measurement. How do we determine significant figures on any value? The method we're going to use is based on if there is a decimal present in the number or absent in the number. So first, if there's a decimal in the number, we're going to start on the left side of the number, skip any and all zeros until you hit the first non-zero digit 1 through 9. The reason we skip those zeros in the front is because they're simply placeholders, making sure the rest of our numbers are in the correct place. Then we will count all the digits after that. So for our first value, we can see that it starts with some zeros. We would skip those and then start counting how many digits we have after that. We have 3 digits, 2, 5, and 0, so that would indicate that this number has 3 significant figures. On the next value, there are no numbers in the front, so we don't have to skip anything. We simply count how many digits we have. We have 4 digits, so this would have 4 significant figures. On the last number, again, we have no zeros in front, so we don't skip anything. And we have 4 digits after that. So this would also have 4 significant figures. The decimal on this value helps us show how far that number can be read with precision from whatever measuring device it's being read from. On the next part, if there is no decimal place, we're going to start from the right side of the number. And again, skip any and all zeros until you hit the first non-zero digit 1 through 9. Then we'll count all digits after. So now we're going to go from the right side because there is no decimal. So since there are a couple of zeros first, we skip those. And then there are 2 digits, 2 and 5. So this would have 2 significant figures. The zeros in this number are not significant like in the last one because we don't have that decimal to indicate how far we can read that number with precision. So the decimal becomes very important to us in these determinations. On the next one, we don't have a decimal, so we would start from the right, and we don't have any zeros to skip, so we have 4 digits, so we would have 4 significant figures. You'll notice on this value that the numbers the zeros that lie in between are counted as significant. Okay. The last part of determining significant figures can deal with exact numbers. Exact numbers are anything that is an exact count, like the number of people in a class or the number of electrons in a carbon atom. And they have an infinite number of significant figures. We would be able to tell if something is an exact number by looking at its units. If its units are something that we can actually count and it's not something we are measuring, then that value would have an infinite number of significant figures. For example, if we had 32 students in our class, we could write this as 32, or 32.000, or 32.00000000000, and those would all be the same. They would all be just as accurate as each other because you can't have partial students. We would never have 32.3 or anything like that. So when it comes to calculations, this rule becomes important. So this is always going to have just an infinite number of significant figures. It's not something that we have to try and give a value to. Let's review what we've learned. First, we looked at how we read measurements properly from a device. We are going to read all markings and estimate one more digit between markings on any device with lines on it. If on the line, the estimate is a 0. We read the bottom of the meniscus for liquids And we want to be careful with burets as the markings are backwards. How we record measurements. We're always going to record all digits on any digital device, and we want to record all values from markings and one more estimated digit on any other device. And then determining the number of significant figures in a value. If something is with a decimal, we read from the left, skip all leading zeros, then count everything from the first non-zero digit. If it is without a decimal, we read from the right, skip all trailing zeros, then count everything from the first non-zero digit. Thank you.